Section 5, Video 3. The next question we're going to do is this example here where we have two equations already solved for a variable. Now this one tends to be a problem for some students for the obvious reason. You have both equations solved for a y, what should I do? Well, again, remember the goal is to have one equation solved for a letter or a variable so we can plug it into the other equation. What's actually happening here is that we have two equations solved for a variable, so we can choose. So I'm just going to take this y value and plug it into the y of the other equation. So basically it looks different because both equations are solved for a variable, but really it just gives us a choice. So here, when we plug it in, we would get 5x minus 4, that's replaced into that equation, and then we write the rest of the equation, 5x minus 2. I combine like terms. What happens is they cancel out, and I have the statement negative 4 equals a negative 2. Now when you go through substitution and you have an equation that's left that has no variables, either you're going to get a true statement or a false statement. If you get a true statement, you will say you have infinite solutions. If you get a false statement, you will say you have no solutions. So basically, infinite means you have, if you were to graph it, you'd graph the line, and you graph the other one, and it's the same line. When you have no solutions, you graph one line and you graph the other, and they're parallel. On a graph, that's pretty obvious. But when you solve by substitution, it's not. So the way we tell is to look at the question at the end and say, what is our statement? There's no variables. Is it true or false? Well, negative 4 is not equal to negative 2. So it's a false statement, which means you will say no solutions. So keep that in mind as you go through your substitution problems. And this ends Section 5, Video 3.